Hello, I'm Mrs. Vaishali Samant. I invite you all to Saraswati Tutorials. If you like my videos, please share and subscribe those videos. Today I will take exponential limits. Formula for exponential limits is limit x tends to 0. Remember, x tends to 0 is there. A raised to x minus 1 upon x means this function and this function should be same. Its value is log of a to the base e. Of course, because log is there, a should be positive. Log of positive number is only defined, that's why a should be positive. There is no proof for this. Direct formula is there. Even this will be useful for 12th standard also. Because 12th standard actually in limits continuity we are using all these functions. Now I will solve some problems based on this formula. If limit x tends to 0, a raised to kx, there is some constant minus 1 divided by x is there. Then because as I told you this and this should be same, I will multiply and divide by k here. And this will be log a according to this formula. And k log a. So you have to remember this formula. A raised to kx minus 1 upon x as x tends to 0 is k log a to the base e, of course. When we are not writing base, it is base e. Now we'll solve some problems. Limit x tends to 0 of a raised to x minus b raised to x upon x. So I will subtract 1 here, subtract 1 here. See, this is minus 1 and this is plus 1. It cancels. So this is okay. I will separate the terms. So this is log a. Limit is there. This is minus log b. So it is log of a by b. So this formula also, if you want, you can remember limit x tends to 0 of a raised to x minus b raised to x upon x is equals to log of a by b. Log of a by b, of course, to the base e. Limit x tends to 0 of 4 raised to 3x minus 1 upon 7x. I will take x here, 1 upon 7 here. And by this formula, it will be 3 log 4. It is k log a, no? So it will be 3 log 4 and this 1 upon 7. So 3 log 4 upon 7 will be the answer for this problem. Now next problem, see, these type of problems are usually asked in the examination. Limit x tends to 0 of 2 raised to x plus 1 minus 3 raised to x minus 5 raised to x upon x. This 2 raised to x plus 1 is 2 raised to 1 into 2 raised to x. So what I will do adjustments here, this is important step here. This is important step, you should remember. 2 into bracket 2 raised to x minus 1 I will take. So minus 2 I have written here, I will adjust that. Minus 3 raised to x minus 1 minus 5 raised to x minus 1. This minus of minus, it will become plus, minus and minus, it will become plus. It will cancel with this. So what extra term I have taken, it is cancelled here. And now I will separate divided by x. This is 2 into log 2. This is minus log 3. This is minus log 5. By theorem on logarithm, this will be log of 2 square. 2 will come here. So log of 2 square, this minus is there. Log of m minus log of n is log of m by n. So it will become divided by 3 divided by 5, it will become 15. So answer is log of 4 by 15. Log of entire thing. It is not log 4 by 15. Remember, log of 4 by 15. Now see here, whenever only x is there, you split up as sum or difference, those terms. But whenever square is there, you have to factorize that so that one x will go with one bracket, other bracket x will go with other bracket. Remember this thing. Only x is there, you have to split up as a sum or difference. See here, and every time you can take x. But x square is there, you have to put it as a bracket of two terms and then one x below one bracket, another x below another bracket. You remember this. Limit x tends to 0 of a raised to x minus b raised to x minus a raised to x minus b raised to x plus 1 upon x square. From these two terms, I will take a raised to x common. So b raised to x minus 1 will remain. I will take minus sign common, minus 1, b raised to x minus 1 x square. I will take b raised to x minus 1 common. So a raised to x minus 1 will be the other factor. And as I told you, square is there, 1x you take here, 1x you take here. This is log a and this is log of b. Log a into log b. Remember this, whenever square is there, what you have to do. And log of a into b, log of a into log of b, don't write log of ab as it is. We cannot solve further. Log of a plus log of b is log of ab. For into we don't know formula. So like this only you have to write. This is also important problem. Another important problem. 4 raised to x by 2 plus 4 raised to minus x by 2 minus 2 upon x square. As I told you, x square we have to factorize this. So first negative I'll bring down. I'll take LCM, it will come down. If I'll take LCM, it's square plus 1 and minus 2 into this. LCM manual take. This is nothing but a square plus b square minus 2a into b. It is whole square of a minus b. So it is whole square of 4 raised to x by 2 minus 1 whole square divided by this x square 4 raised to x by 2. Now what I will do, 4 raised to x by 2 minus 1 upon x, it is whole square, and this 4 raised to x by 2. And this I want 2 here, multiply and divide by 2 here, because here x by 2 is there, same function should be there, multiply by 2 and divide by 2. Or without multiplying also you can do a raised to kx minus 1 upon x is k log a. So here k is half. So without multiplying also you can do an adjusting. So it will be half log 4 and its whole square. And when I'll put x is equals to 0, this becomes 1. Anything raised to 0 is 1. So this will be 4 raised to half. This half will come here. And this 4 raised to half is 2. So it is log of 2 whole square. Remember, it is not log of 2 square. It is log of 2 whole square. Log of 2 square is different from this. This means log 2 into log 2. Be careful here. So without multiplying and dividing by 2 also, a raised to kx minus 1 upon x formula if you use, you will get half log 4 whole square, and you can solve it like this. Next problem is limit x tends to 0 of 3 raised to sin x minus 1 upon x. So same function must be there. So I will write sin x here. I will multiply and divide by sin x. And as you know, x tends to 0. This is also 0. This is also 0. So it is just like a raised to x formula. A raised to x minus 1 upon x. So its value is log 3. And this sin of x upon x, you know it is 1. So answer for this problem is log 3. Another problem is x tends to 3 of 4 raised to x minus 64 upon x minus 3. As I told you, when x minus 3 is there, you have to put x minus 3 as y. So x tends to 3, y will become 0. When x is 3, y will become 0, and x will be y plus 3. So substitute here y tends to 0. Remember, you have to change everything in y. 4 raised to y plus 3 minus 4 cube upon 3. This is 4 raised to 3 into 4 raised to y. So 4 raised to 3 you take common. So it will become 4 raised to y minus 1 upon y. As y tends to 0, we know formula. This is log 4. And this 4 raised to 3 is 64. So this is your answer. Even this problem x tends to pi by 2. Pi by 2 minus x is there, no? As I told you, pi by 2 minus x is equals to y. So as x tends to pi by 2, y becomes 0. And x, if you will bring here, it is y by 2 minus y. And cos of x we want. So cos of x is cos of pi by 2 minus y. Cos of 90 minus theta is same co-ratio. And it is in the first quadrant positive. Pi by 2 minus something in the first quadrant is positive. So it is sin y. So this will become limit y tends to 0 of pi raised to sin y minus 1 upon y. So sin y I will divide and multiply like previous problem. And this is log 5. And this is 1. This is 1. And therefore answer is log 5. Formulas I am writing again. X tends to 0 of a raised to x minus 1 upon x is log a. So if I will take e raised to x minus 1 upon x, it will be log e. But log e is 1 because base is e. In mathematics everywhere we take base e. Because formula itself is for base e only. Similarly, a raised to kx minus 1 upon x as x tends to 0 is k log a. So instead of a, if I write e here, it will be k log e to the base e, and this is 1, so its answer is 1. So you have to remember answer for this as x tends to 0 is 1, and answer for this as x tends to 0 is k.